So hello everyone. In today's lecture, I will be talking about the joints of the shoulder region. And again, so I will keep it short. So I will divide the lecture into two smaller segments. Each one will be about 10 minutes. So I hope that will help you to keep focus. So let's start. Before I go into the joints of the shoulder region, I just want to show you something, about the anastomotic network around the shoulder region. So here is the shoulder region. So you can see these are the joints here, the shoulder joint and the acromioclavicular joint. So in this area, you can see a lot of arterial anastomosis, which is common actually. If you see other big joints in the body like elbow joints, knee joints, you see this type of arterial anastomosis around the joints. So that is true in case of shoulder joint as well. As you can see these vessels, so this one is, you are familiar with this one, this is the suprascapular artery. You see the suprascapular artery is entering the posterior shoulder region just over this ligament. You see this ligament, this is the notch in the upper border of the scapula. And do you remember we said the army over the bridge? So it's a suprascapular artery is passing to the posterior shoulder region over that bridge of that ligament, okay? And so that is, and suprascapular artery is a branch of thyrocervical trunk. You can see here, we will be talking about those vessels later. So anyway, the branches of arteries that take part in this anastomotic network are suprascapular artery. Another one, this one is a deep branch of the transverse cervical artery, which is a branch of transverse cervical artery. And you can see this anastomotic network between those two arteries. And then you see another artery that is joining here this is axillary artery, okay? And then you can see a big branch coming from the axillary artery is the subscapular artery here. And subscapular artery will give a branch which is called circumflex scapular artery. Okay, circumflex scapular artery, which is a branch of subscapular artery. Subscapular artery is a branch of axillary artery. You remember circumflex scapular artery that entered the posterior scapular region or posterior shoulder region through the triangular space. Okay, we talk about the quadrangular space, the triangular space. So this one come out to the triangular space and also participate in this arterial anastomosis. And another important anastomosis is between the posterior circumflex humeral artery. Again, remember this artery entered the posterior scapular region or posterior shoulder region through the quadrangular space, right? Posterior circumflex humeral artery, and the artery that goes anterior to the humerus is the anterior circumflex humeral artery. They also join together and form an anastomotic network. Now, what is the importance of this anastomotic network? If you see, so for an example, if the axillary artery is blocked in this region, okay, so that the blood cannot travel through the distal to this blockage because it's blocked here. So in that case, because of the presence of these alternate routes, the blood can travel through like this or a branch, a branch this. And so this is bypassing the blockage, right? And then they come like this through any of the anastomotic network. The blood can return to the axillary artery, which is distal to this blockage. So this blockage is bypassed by the blood traveling through this anastomotic network and then going through the circumflex scapular artery and subscapular artery back into the axillary artery, which is distal to this blockage, okay? So that is an importance. But only thing, you see, one thing is that normally blood travels through the axillary artery and subscapular artery, but in this case, because of the blockage here, blood is traveling through the anastomotic network. Now, blood is flowing in counter direction in the subscapular artery to reach the distal part of the axillary artery. So that is an important of this type of anastomotic networks, and you will find them, which is common to find around the joints. But let's take another example. If you have the artery, by this time, this is not axillary artery anymore. Axillary artery changed its name to the brachial artery here. Now, if you have a blockage here in the brachial artery, now you don't see any, alternate routes actually. So if you have blockage here, not enough blood will flow beyond this blockage to supply the area which is normally supplied by this particular artery, this part of the brachial artery. So that's why blockage here is you have enough collateral pathways or so bypass pathways so that blood can still flow beyond this blockage. But if you have blockage around here, because of the absence of collateral networks, the blood cannot flow, enough blood cannot flow distal to this blockage. Okay, so that is an important factor. So that's why I thought I mentioned it before I go into the joints of the shoulder region. Now let's start talking about the joints. We have two joints here. One is acromioclavicular joint between the acromial end of the clavicle. Look at clavicle here. We are familiar with clavicle now, and this is the acromion process of the scapula. Okay, so acromion is articulating with the acromial end of the clavicle. And then another joint in this area is the glenohumeral joint. You know, in layman's term, we call it shoulder joint. And shoulder joint is another articulation between the head of the humerus and the glenoid cavity of the scapula. Okay. Now, so one thing is common between both of these joints, acromioclavicular joint and the glenohumeral joint, is both of them are synovial joint. You see, the joints in our body are divided into classified into three main groups, depending on how they are. Joint is a union of two bones, and depending on the type of junctions, they are divided into three classes. One is we call membranous joint, where two opposing bones are united by a membrane. Like, for an example, if you look at the bones of the forearm, there are two bones there in the forearm. One is like radius and ulna, right? Now, radius and ulna are joined together by an interosseous membrane, which is a fibrous structure. That's why it is classified as fibrous joint. And another joint is between the most commonly, you see, this is the vertebral body, this is another vertebral body, and in between the vertebral body, two adjacent vertebral bodies are united by a piece of cartilage here. So it is this piece of cartilage that is joining these two bones, two bodies of the vertebrae. Okay, so this type of joint is called the cartilaginous joint. But most of the joint of our body are classified as synovial joint, and both the joints in shoulder region, acromioclavicular joint and glenohumeral joint, this one acromioclavicular joint and glenohumeral joint, both of them are classified under synovial joint. Now, because we are talking about synovial joints, let's quickly review the characteristics of a typical synovial joint. Okay, so synovial joints are the joints where two opposing bones, so see, this is one bone and this is another bone, and they are joined together by this thing, by a joint capsule. Okay, so when two opposing bones are joined by a joint capsule, those type of joints are called synovial joints. Now, synovial joints have some typical features. Now, see, one of them is articulating bones are joined, united by a joint capsule. See, these are the two articulating bones, and they are joined by a joint capsule. Okay, and also the articular surfaces of this bone and this bone, they are covered by cartilage. We call them articular cartilage. Okay, articular cartilage cover the opposing bones. Okay, and also, see, if you see the fibrous capsule of the joint, that is lined inside by a membrane called synovial membrane. Okay, so this is synovial membrane that line the inside of the fibrous capsule. Now, this synovial membrane and fibrous capsule of the joint together are called the joint capsule, which means joint capsule has two components. One is the fibrous capsule, which is this one, and the synovial membrane, which is shown in red. Okay, and another feature of the synovial joint is that there is a joint cavity. Okay, joint cavity, and it contains thin film of fluid. So this is a cartoon. Normal joint doesn't have this big a joint cavity. This is inflated joint cavity. Actually, joint cavity normally is a potential space, which means it is not a real space actually, but that has a very thin film of fluid. Okay, so again, what are the criteria of synovial joint? The two opposing bones are joined together by a joint capsule, and then the fibrous capsule is lined inside by the synovial membrane, joint has a potential space called joint cavity, which contains some thin fluid, and the two opposing bones are covered by articular cartilage. Okay. So now let's get to a real joint. Okay. So now acromioclavicular joint. Now acromioclavicular joint, see, this is that we said it's a synovial joint, which means two bones are united by a joint capsule here, and then thickening of the joint capsule in the joint, in a synovial joint, form ligaments to support the joint. Okay, so and then this is called the acromioclavicular ligament, which is formed by the thickening of the fibrous capsule of the joint. Okay. And if you see in a section, you see this is clavicle, this is acromion, and you can see opposing surface of the bones are lined with the joint capsule. Not joint capsule, actually, the articular cartilage here you can see. And then this is the joint capsule, and the thickening of the joint capsule here form the acromioclavicular joint. So another ligament here I want to mention is this one. This is a much stronger ligament than acromioclavicular ligament, which is called coracoclavicular ligament, which is a ligament between the clavicle and the coracoid process of the scapula. Okay, this ligament is much stronger than this one and provide a lot of stability to the acromioclavicular joint. Okay, and when we talked about clavicle, we talk about the trapezoid line or the conoid tubercle on the undersurface of the clavicle, and now we know why we call a place the trapezoid line, a line called trapezoid line, because it provides attachment to the trapezoid part of the coracoclavicular ligament, and conoid tubercle provide attachment to the conoid ligament, which is also a part of the coracoclavicular ligament. Okay, so now acromioclavicular joint, can be dislocated as a result of trauma. Now, if the trauma is minor, only this, this ligament is torn, the acromioclavicular ligament, so the joint is dislocated. But even when only this ligament is torn and the acromioclavicular joint is dislocated, still there is a communication between the scapula and the clavicle through the much stronger coracoclavicular ligament. But in case of severe trauma, if this ligament is also torn, so then the scapula will be completely separated from the clavicle. Okay, that is called the shoulder separation. If that happens in a severe trauma, if both the ligaments are torn, then clavicle will be pulled up by the other muscles, like for an example, sternocleidomastoid, that will pull the clavicle up, and the shoulder will drop down because of the weight of the upper limb. So, and that is called the shoulder separation. So, I think that's all I have to say about the acromioclavicular joint. On the next video, again, it will be again another short one, and I will cover the shoulder joint and the movement of the shoulder joint in the next one. Thank you.